The moment 3i Atlas passed by Mars should have been a milestone in human history. For the first time, we had a perfect chance to observe an object from beyond our solar system, close enough for the satellites around Mars to capture every detail of it. But just at that critical moment, NASA, the world's leading space agency, suddenly stopped sharing its data with the public. What was really happening? Was it just a coincidence, or is there a hidden secret about the universe that we were never meant to know? That shutdown didn't just make the data disappear, it turned 3i Atlas into the most mysterious object humanity has ever encountered. On October 1, 2025, the United States government officially entered a shutdown. Across the country, offices went dark, budgets froze, and tens of thousands of federal employees were told to stay home. For NASA, it meant silence. Almost 85% of its workforce was placed on leave, websites stopped updating, and a single message appeared on its homepage. Due to a lapse in funding, this site is not being updated. At first, people thought it was just another bureaucratic pause, a familiar political routine that happens every few years. But this time was different. Because at the exact same moment, a mysterious visitor from beyond our solar system was approaching Mars, the interstellar object known as 3i Atlas. It was the third object of its kind ever detected, and its path was bringing it closer to another planet than any before it. For astronomers, this was the perfect window to study something that did not belong to our solar neighborhood. Every major space agency had prepared for this encounter. The Mars Reconnaissance Orbiter, MAVEN, and Perseverance rover were all expected to collect and transmit data as 3i Atlas made its closest approach, only 28 million kilometers from Mars. It was supposed to be a golden moment for science, the kind that could redefine what we know about how objects travel between stars. But instead of headlines and images, the world got nothing. No signals, no live feeds, no updates from NASA's official channels. Every public system suddenly went quiet, just as the object entered range. To many observers, it felt like watching history happen behind a locked door. Even the independent tracking pages used by amateur astronomers froze at the same time, as if every channel connected to NASA had been disconnected from the outside world. Scientists and journalists tried to reach NASA's press team, but all inquiries were met with the same automated reply: operations are temporarily suspended. For days, the silence continued. The live streams that once showed daily updates from the Mars surface were taken offline, and the agency's social media feeds stopped posting entirely. Researchers who relied on NASA's open data servers reported missing logs and inaccessible files. No one could explain why the shutdown seemed to affect space communications so severely. Officially, NASA's core missions were still running. Critical systems that protect spacecraft and astronauts were not supposed to be affected by the government freeze. Yet somehow, every public-facing channel went dark at the same time 3i Atlas came into view. That timing alone sparked a storm of speculation online. Space forums filled with questions. Was the blackout planned? Was it a coincidence or something deliberate? People began comparing the event to earlier shutdowns, but none had ever silenced NASA this completely. Some experts suggested that even during funding lapses, robotic missions like Perseverance or the Mars Reconnaissance Orbiter usually continue operating autonomously, sending data to be stored for later. That means the information might still exist somewhere, just hidden from the public. As the days passed, the silence became heavier. Astronomers began calling that week the week the sky stopped talking. What could have been the most important observation in decades vanished into a void of uncertainty. So people started asking the one question no one could answer: why did NASA go silent right when 3I Atlas appeared. When 3I Atlas was first detected, no one realized how different it truly was. Astronomers thought it might just be another icy traveler, drifting through the void like 1,000 comets before it. But as the data came in, one thing became clear. This object wasn't following the rules. It was moving at a speed of nearly 200,000 miles per hour, slicing through the inner solar system on a path almost perfectly flat with the plane of the planets. That alone was strange. Most interstellar objects, like Oumuamua or Borisov, entered from above or below the solar system's disk, diving in at steep angles before vanishing back into space. 3I Atlas didn't do that. It traveled with the planets, not against them, as if it had chosen to blend into our orbit rather than cross it. That was the first sign that something about it was different. Its estimated size also defied expectations. Based on light curves and spectral data, scientists believed it was at least 5 kilometers wide, almost 3 times larger than Oumuamua. That made it too big to be a simple fragment of cosmic debris. It was massive enough to hold its shape even as it passed through the solar wind, where smaller bodies would have broken apart. Then came the color. 3I Atlas wasn't gray like an asteroid or blue-white like a comet. It glowed a deep emerald green, a hue that intensified as it neared the sun. Spectroscopic readings revealed something that shocked researchers. The ratio of carbon dioxide to water vapor was reversed compared to any known comet. That meant it had likely formed in an environment far colder than any region of our solar system, perhaps in the dark outskirts of another star system entirely. And yet, despite that, it was strangely active. Even while far from the sun, it released gas and dust as if it were being heated from the inside. Scientists couldn't explain it. Some said it was a chemical reaction triggered by unknown materials beneath the surface. Others suggested a form of internal heat, something that kept it alive long after it left its home star. Whatever the reason, it didn't behave like anything natural we'd seen before, but what really made astronomers pause was its anti-tail. Unlike a normal comet, which trails a bright tail of dust away from the sun, 3I Atlas seemed to have a faint tail pointing toward it. Only a few comets have ever shown this kind of structure, and usually only under rare optical conditions. Here, it appeared clearly in multiple observations. The anti-tail followed the sun's direction perfectly, suggesting that the object wasn't being pushed by solar radiation, it was resisting it. That shouldn't be possible. Solar radiation exerts pressure on any reflective surface, even weakly. So for 3I Atlas to maintain a forward-facing tail meant that something else was influencing its motion, maybe even controlling it. Then came the solar storm. On October 6th, a massive coronal mass ejection erupted from the sun, blasting charged particles across the solar system. Most comets would flare up or fragment when hit by such energy, but when the plasma wave reached 3I Atlas, nothing happened. No change in brightness, no deviation in trajectory. It simply kept moving as if the storm had never touched it. That single observation confused even the most skeptical scientists. Either it was incredibly dense, made of materials far stronger than rock or ice, or it was shielding itself somehow. Both explanations sounded impossible, but the data didn't lie. The object's stability under such extreme conditions made it an even more valuable target for study. If researchers could track how it interacted with light and gravity, it might reveal entirely new insights into how matter behaves beyond our solar system. But right when telescopes were ready to collect those answers, NASA's data feeds went dark. For the first time in history, humanity had a front-row seat to watch an interstellar object pass near another planet, and our main window to the event closed. To some, that silence made 3I Atlas seem even more alien. Its timing was too perfect, its behavior too organized, its resistance to natural forces too strange. It didn't act like a comet. It didn't drift like an asteroid. It moved with purpose. Even now, the object's approach remains one of the most mysterious events ever recorded by astronomy. And if everything about it broke the rules of physics, maybe it's time to ask the next question. What if 3I Atlas wasn't just a visitor from another star, but something built to find us? When NASA's data stream suddenly stopped, confusion spread everywhere. People expected daily updates, new images, and news from Mars, but instead, they got silence. Why did it happen at the exact moment 3I Atlas, a once-in-a-lifetime interstellar visitor, was passing closest to Mars? Scientists and space fans around the world started discussing possibilities, trying to make sense of what was happening. The first and most logical explanation was coincidence. NASA's public systems are connected to the US government's funding schedule. When a temporary shutdown happens, many offices pause operations, including websites and media channels. That doesn't mean missions in space stop. Most continue running automatically. Robotic spacecraft like Perseverance, MAVEN, and the Mars Reconnaissance Orbiter are built to work without constant commands from Earth. They can keep gathering information and store it safely until teams return to process it. So the data probably still exists, just waiting to be reviewed and shared. Many experts believe this was simply unfortunate timing, a scientific opportunity arriving right when normal communication channels were paused. Still, that timing made people curious. Across social media, others began sharing another idea, one focused more on caution than mystery. Some scientists suggested that NASA might have chosen to delay releasing data about 3I Atlas until it could be carefully verified. This wasn't about secrecy, it was about accuracy. When something as rare as an interstellar object appears, the information needs to be double-checked before going public. Even a small mistake could spread misinformation or cause confusion about what was really seen. According to this view, NASA's silence wasn't a cover-up. It was simply part of a responsible process to make sure the science was right. That made sense to many professionals who work with large observatories. They know how long it can take to confirm new findings, especially when multiple telescopes and spacecraft are involved. Meanwhile, others thought the agency might have wanted to prevent speculation during a politically sensitive time. Whenever space discoveries go viral online, theories about aliens or secret technology often appear immediately. So some communication experts felt it was safer to wait until all the information was reviewed before making announcements. Whatever the reason, most scientists agreed on one thing: the data wasn't gone, just unseen. NASA systems are designed to protect information until it's ready for release, and when the government reopened, that data would likely become available to the public. In the end, it might all come down to patience. Still, one thought lingered. If NASA really did record 3I Atlas during its flyby, those files could hold the most detailed look at an interstellar object in history. And soon, that information might reveal not just what this strange object was, but how it behaved when it passed so close to another world. Could the next release of data finally show us what 3I Atlas really looked like near Mars? The silence from NASA didn't last forever. While the public waited for answers, the machines on Mars kept doing what they were built to do: watching, recording, and sending data back home. And that's when something unexpected happened. On Sol 1643, or October 2, 2025, the Perseverance rover captured a routine set of night images from the Martian surface. At first glance, everything looked normal: dark skies, faint stars, and the quiet emptiness of the red planet. But then, in one frame, a strange bright streak appeared, cutting cleanly across the horizon. It wasn't blurred like a meteor, and it didn't pulse like an electronic error. It was steady, sharp, and perfectly straight. When scientists matched the timestamp with orbital predictions, they realized the streak aligned exactly with the position of 3I Atlas at that same moment. In other words, the rover might have captured the first ever image of an interstellar object passing near another planet. The picture appeared briefly on NASA's public archive, long enough for a few researchers and space enthusiasts to download it. Then, suddenly, it vanished. The file was removed from open databases, leaving behind only traces in cached web pages. Inside NASA's internal logs, the image carried a cryptic label, "Anomaly confirmed." That single note changed everything. If this was just a data glitch or dust reflection, why call it an anomaly? And why take it down so quickly? As people tried to make sense of it, reports began emerging that Perseverance wasn't the only one to detect something unusual that night. Orbiters circling Mars had also picked up strange readings. The Mars Reconnaissance Orbiter, MRO, detected a thin band of ionized plasma glowing faint green at high altitude, something never seen before on Mars. Its wavelength, around 530 nanometers, matched the glow of auroras on Earth, except this one appeared where no Martian aurora should exist. Meanwhile, the Trace Gas Orbiter, TGO, operated by the European Space Agency, ESA, recorded sudden fluctuations in methane and carbon dioxide in the same region. These gases shifted too rapidly to be caused by natural cycles, and they came from above the atmosphere, not below it, following the projected path of 3I Atlas. Then came data from Mars Express, another ESA spacecraft. Its radar system caught a sharp reflection burst lasting 4.7 seconds, strong enough to suggest contact with something metallic or highly charged. Too short to be static interference, too long to be a glitch. Together, the readings formed a pattern, a consistent anomaly moving across Mars's orbit exactly when 3I Atlas passed by. None of this was ever published in official reports. The public pages stayed blank, and no one at NASA or ESA made formal comments. But metadata from independent archives confirmed the instruments were active at that time. Weeks later, an ESA researcher anonymously told Nature Astronomy, "The data is there. It's just not ready for release." That quiet confirmation spread quickly through the astronomy community. If true, it meant humanity had caught a real glimpse of something from another star system, maybe even its first recorded interaction with a planet beyond Earth. The mystery deepened. Every removed photo, every missing log hinted that Mars had witnessed something extraordinary. Something we weren't meant to see, at least not yet. So what exactly did Perseverance capture that night, and why did the images disappear so fast? When the first bits of data finally came back, scientists realized something about 3I Atlas didn't make sense. The numbers looked normal at first, but the more they compared them, the stranger they became. The light coming from the object wasn't behaving the way it should. Normally, when sunlight hits dust or rock, it scatters in a predictable way. But in this case, the light was bending differently, almost like it was being reflected off something smooth and metallic instead of ice or stone. Measurements showed an on-polarization level of -2.77%, which basically means the light was twisting in a direction opposite to what scientists expected. That kind of reading usually only happens when the surface is made of something shiny, dense, and uniform, like metal. For a comet or asteroid, that was unheard of. Even more surprising, 3I Atlas didn't react to the massive solar storm that hit on October 6th. When the sun releases a burst of charged particles, it normally causes comets to flare up or drift slightly off course. But 3I Atlas didn't even flicker. Its orbit stayed perfectly steady, as if the storm had never happened. teams at NASA's Jet Propulsion Laboratory, JPL, ran simulation after simulation, trying to figure out why. The only explanation that fit was that the object had to be much heavier and tougher than anything made of ice or rock. It could even have a thick metallic shell protecting it from radiation. That kind of structure would be extremely rare, if not impossible, for something that formed naturally. Then researchers looked again at the radar data from ESA's Mars Express. They found that the short echo lasting 4.7 seconds wasn't random noise. The returning signal had repeating peaks, almost like sound waves bouncing off different layers inside the object. It hinted that 3I Atlas wasn't a simple solid mass, but maybe had internal layers, or even hollow spaces, that caused the reflection to pulse in rhythm. It was the kind of pattern scientists usually see in artificial materials, not random cosmic debris. At the same time, the James Webb Space Telescope recorded something even more unusual. As the object approached Mars, it became 17% brighter, reflecting more sunlight than before. But instead of continuing to brighten like most comets do, its reflection suddenly stopped changing. It leveled out as if it had reached a limit or made a decision. To some researchers, it looked like 3I Atlas was adjusting how much light it absorbed. That kind of behavior reminded them of solar panels, which regulate energy by turning light into power. No one was claiming it was technology, but the idea stuck. If this object could control its reflection, it might not just be surviving sunlight, it might be using it. Of course, not everyone agreed. Many scientists still believed it was a frozen object from another star system, covered in strange materials that reflected light in unusual ways. But others saw a deeper mystery. Maybe 3I Atlas wasn't just a rock. Maybe it was the remains of something ancient, a fragment of a world that once existed, or even a piece of something built long ago for a purpose we no longer understand. Every new discovery only made the questions bigger. It looked metallic. It ignored the sun's storms. It reflected light like it was alive. And yet, no one could explain how or why. By this point, 3I Atlas wasn't just a visitor from another system. It had become a challenge to everything we thought we knew about the universe. While NASA remained silent, other nations quietly stepped forward. Across Europe, Asia, and the Middle East, space agencies launched their own investigations into 3I Atlas, each hoping to capture the data the United States could not. The European Space Agency, ESA, was the first to break the silence. In a short but carefully worded statement, ESA confirmed that Mars Express and Trace Gas Orbiter had continued monitoring the interstellar object throughout early October. Their message was brief. Observations of 3I Atlas remain ongoing and promising. Behind those words, Europe was mobilizing a massive scientific effort. ESA redirected its deep space radar arrays across Spain and Argentina, linking the Cebreros, New Norcia, and Malargüe antennas to track the object's faint light curve. Ground telescopes such as the Very Large Telescope, VLT, and La Silla Observatory in Chile joined the network, searching for rhythmic changes in brightness that could reveal how 3I Atlas was rotating. They soon found a pattern repeating every 11 hours, suggesting the object might be slowly spinning or reacting to sunlight in a way no comet ever had. To verify this, ESA planned to use its upcoming JUICE spacecraft, originally designed to study Jupiter's moons. By November 2025, JUICE would pass near the object's path and use its UV spectrometer and sub-millimeter wave sensors to capture high-resolution data. But since the probe was behind the sun, everything it recorded would remain stored until February 2026, when Earth regained contact. At the same time, ESA was investing heavily in its next generation of observatories. The Extremely Large Telescope, ELT, and Athena X-ray Observatory, both under construction, were designed to scan deep space for future interstellar visitors, ensuring events like 3I Atlas would never go unseen again. While Europe prepared, Asia was already watching. China's Tianwen-1 orbiter, still circling Mars, reprogrammed its radar to scan the same region where ESA detected the anomalies. Internal reports mentioned faint but repeating energy spikes near the object's predicted path. In Japan, JAXA brought together the ALMA array and Subaru telescope, combining radio and infrared observations to detect possible magnetic fields around 3I Atlas. Japan also accelerated construction on the 30-meter telescope, TMT, one of the largest optical telescopes ever built, designed to study fast-moving interstellar bodies with extreme precision. The United Arab Emirates, operating the HOPE orbiter, maintained constant visual tracking from Mars orbit. Free from political shutdowns, its instruments kept recording without interruption. Still, Emirati scientists confirmed that their full findings would be shared only after cross-analysis with ESA and JAXA, likely sometime in 2026. Back on Earth, private observatories joined the effort. The Indian Astrophysics Network, South Africa's Meerkat Array, and several Japanese telescope groups reported faint green-white flashes about 30 million kilometers from Mars. The lights were too steady to be cosmic rays and matched 3I Atlas's projected path perfectly. Many officials dismissed them as solar interference, but amateur astronomers disagreed. They believed they were witnessing real evidence of the object's passage. By mid-October, it was clear the silence didn't mean ignorance. ESA, China, Japan, and the UAE were gathering data, upgrading instruments, and coordinating global radar coverage like never before. Billions were being invested in new telescopes and deep space tracking systems to make sure humanity would never be blind to the universe again. It wasn't a blackout anymore. It was a global pause, a moment of waiting before something extraordinary was revealed. Because maybe what they found about 3I Atlas wasn't only about science. What if the data they were holding could change how we understand the universe, or even what we believe is possible out there? In the end, the mystery of 3I Atlas is not just about what it was, but what it means. A silence at the height of discovery, data that vanished, and signals that didn't fit any known model, all remind us that the universe still holds secrets beyond our grasp. Whether 3I Atlas was a natural wanderer or something created with intent, its passing forced humanity to confront a larger question: how much of the cosmos do we truly understand? And if the next visitor is already on its way, will we be ready to face what it brings?